Two and a Half Admins, episode 8. I'm Joe.
I'm Jim.
And I'm Alan.
And here we are again. And before we get started, a couple of things to plug. These FreeBSD Friday streams.
Yeah, so each Friday for the next while anyway, there'll be a live stream with some intro to FreeBSD content. I think there was last week's was just an intro. The one coming up this week is an install fest. And then I think there's a more in-depth lecture coming the week after that, and a whole series of different things planned. So if you are interested in FreeBSD and want to get started, the FreeBSD Friday streams are a nice way to relax on a Friday and learn about BSD.
Are we going to see you on there at all?
Probably eventually.
Okay, cool. So also, I want to plug my services. If you want your podcast to sound good or better, then get in touch with me at joeress.com, joeress.com. There's various ways to get in touch with me there, whether it's pre-production, recording, or post-production. I can make your podcast sound better. So let's do some news stories. A couple of them you wrote, Jim. The first one about these new Western Digital drives, which are EAMR, and they're in 18 and 20 terabyte variants.
Yeah, and the 18 terabyte variant is not SMR, and the 20 terabyte variant is, but it's host managed. So the SMR drives that have really got everybody up in arms are all drive managed, and it's very important to draw the distinction between the two. A drive managed SMR disk will just plug into your machine, and if you don't hit it with a workload that it can't handle, you may not realize what you've done until all of a sudden it falls off a cliff. Now, host managed SMR just flat won't work when you plug it in unless you're actually running, specialty drivers to manage the thing on the system, which on Linux, that would be DM Zone D. I have no idea, honestly, how you mess with those things in Windows.
Yeah, generally with a host managed drive, if you try to write to an offset that isn't just appending to an existing zone, it's just no, you can't do that. If you try to write 512 bytes to a 4K native drive that doesn't do 512 byte sector emulation, it just says that's an invalid size. And so that's interesting. I'm guessing they only managed to get to 20 terabytes by doing SMR. And basically it's the same drive as 18 terabyte, just using SMR to stretch out that extra couple of terabytes. The interesting thing here is to see them going with the energy assisted recording rather than, it seemed like Western Digital was going to go with the microwave assisted.
They haven't given up on MAMR yet. They're still working with that, and they may still release drives that are using it. I think the issue here is just that the EAMR is so much less exotic that, when they found out that using that technology was enough to get the density, it was easy to get a product to market that way.
Well, yeah, because I think the biggest concern with both MAMR and Hammer was the fact that they generally needed to use a different material for the disk platter itself that would handle being heated up and cooled down constantly. And as soon as you start changing something fundamental about that drive, you ran the risk that, 2 years into their service life, something unpredictable was going to happen.
Yeah, it's not just that the platter had to be, capable of withstanding being heated up and cooling down. I don't think that's even the primary issue. The thing is, you change the media to something that is considerably more magnetically coercive, meaning it's harder to change the state on it. That's what actually allows you to get the greater density. The problem is that your write head now is not strong enough to overcome that magnetic coercivity. And the laser or the microwave is what temporarily changes that property on just the area you're writing to at that moment. So that's everything that you got to do to make that work. Now with the YAMR, which is just how I'm going to pronounce that EAMR thing. With YAMR, it's a lot simpler. Now you've just got a bias current that's running on the main the main pole of the write head, as well as the voice coil that runs on the smaller voice head. Now this steady bias current allows the field to come off of the voice coil. It ramps up a lot more quickly and accurately so that you can affect a smaller area of the exact same platter than you would otherwise be able to. But it's one of those things that it's a lot less exotic, but if you're the right kind of engineering nerd, that makes it really cool. Because it's like, hey, look at this simple thing that we did to, get a lot more performance than we had to without doing all this crazy, weird overboard stuff.
Well, that was my next question. How does the performance compare with the conventional magnetic drives?
Well, so according to Western Digital, there's no performance impact whatsoever. I'm working with them as we speak, trying to make sure that I can get one of those discs as quickly as possible, get my own grubby hands on it and find out, hey, is that actually the case or not? I don't have any reason to disbelieve them. It's literally not my day job to just blindly believe what the vendor says.
Yeah.
But yeah, in general, we've not seen that much change in spinning disk performance in a long time. It's just been, you have a head that can do so many IOPS, and we pack the data closer together, which has given us faster throughputs, but that's about it. And so, yeah, I wouldn't expect to see much in the way of performance difference from this.
We could actually see, some moderate performance improvements compared to some disks, because there are some other innovations in those 18 and 20 terabyte disks. They are supposedly the first disks to make it to market with 9 platters, and they also are the first ones to have a triple stage actuator rather than dual, which basically is like, look at your finger. You've got 3 places your finger bends, right? Well, it's the same thing with Western Digital's actuators in these large drives. Much like your finger, the grossest movements come from the closest part to your hand. Now, on the disk, of course, that's going to be the closest to the outside of the disk. So the closer you get to the interior of the disk, the finer the motion that you've got of the actuator at that stage. So basically, you can make a really rapid sweeping motion across the disk rapidly, and you can fine tune to exactly where you want to be with the little joints further in. Now, whether that's really going to translate to an enormous performance difference or not, I don't know. We'll find out, but hopefully something.
It'd be really interesting if we see a change in IOPS compared to other drives, because, basically IOPS on spinning disks have not really changed at all in a long time. And it's resulted in the IOPS per terabyte going down, because the terabytes keep going up and the IOPS don't. And that's why I was really interested in Seagate's multi-actuator drives. But so far, the only one they've produced basically connects to a SAS port and appears as 2 separate drives. So it's one drive where one actuator reads half the disk and one actuator reads the other, and it just shows up as if it was, it basically uses SAS multiporting, but one drive on each of the 2 ports.
It's an old school single-sided floppy drive again. You just pull the platter out, flip it over, put it back in. Hey.
Well, in this case, you can use both at the same time. So
yeah.
If you don't mirror them together, but if you use 2 of them and mirror the halves together, suddenly you have spinning disks that you can do 450 to 500 IOPS, which is a nice improvement. But there's so many things that are weird about it that it hurts the usability bit.
Or you just use merger FS off the 2 actuators so that you have like one drive again. Seems kind of weird they didn't do something similar to that in the firmware.
Well, because they looked at, we could just, if we did like every other sector or something, then the problem with that is you're not going to get any better random performance, because you're going to have to move the other, they're going to have to almost track together. And if you do something like zones, like you say 1 megabyte or 32 megabytes or 256 megabyte zones are all on one, and then you alternate to the other, you still end up with, if you're trying to read a file that's, you wrote out sequentially, it's going to require both heads to be in the same place, and you're not really getting the advantage. And, if you look at a typical file system, it generally fills from the front to the end, meaning if you just did the first half of the drive uses this actuator and the second half uses the second actuator, the second one's never going to have any work to do. And so trying to do it in a way that it would map to older file systems seemed difficult. And so sometimes they thought, if we split the drive in half and expose it, as long as you make sure you don't, mirror crop the two halves of the same drive, then in your, some kind of RAID setup, it could make sense and give you the IOPS.
I'm just surprised they didn't do a drive managed and say, oh, this looks like one single disk, but, you feed us your queue of operations and we'll accomplish it with whichever actuator is more convenient.
I think because of the way they're physically built, each actuator can only reach half the drive.
Oh, okay.
Somehow. I'm not entirely sure how it works.
So I was assuming more like you've got one actuator on either side of the platter, so that, they're basically 180 degrees removed from each other at all times. But if you don't have the bit that you want at that moment, wait a millisecond and it'll be under the head.
That's kind of what I was expecting as well. I saw one short demo of it, and that's all I've seen so far. I haven't managed to get my hands on one.
They've tried building drives with multiple actuators like this before, and one of the very basic engineering problems, like, have you ever had like a Western Digital Velociraptor The old 10K RPM drives.
Yeah, I had the one of the like 73 gigabyte ones.
Yeah. Those things. It sounds like a freaking coffee grinder when those things are running, right? I mean, It's a significant amount of vibration that you're adding to the environment every time that head slams, from one position to the other on the disk. And if you've got two of them doing that, they're each jarring the other, and you end up introducing so much more chaos into what's going on that you don't really get much actual benefit out of it.
Yeah.
Yeah, and there's more mechanical moving parts, so there's more to go wrong, right?
That too.
Well, yeah, that was the other interesting bit that was being talked about a couple of years ago now. But, apparently larger cloudish companies like Facebook and so on is like, yeah, if one of our platters dies, we'd like the disk to just be like, all right, you can't use that platter now, but keep working with the rest of the data. And it's like, how often does disk fail where it's only one platter that doesn't work? What file system is really going to handle that?
Well, I can pretty easily see, I don't think it's necessarily the file system so much as, your multiple disk topology. That does seem like something that would be fairly easy to work around. It just strikes me as, kind of trashy in the extreme to be like, oh no, the rest of this disk is fine. It's like eating around the rotten part, and the leftovers that came out of the fridge that have been there for 3 or 4. No, man, throw that away.
Yeah.
All right. Well, speaking of disks that are failing, there's a story from Hackaday that you found this week, Alan, about using DD Rescue.
Yeah. So first thing, hope that you never need to use DD Rescue.
Yeah.
If you're having to use DD Rescue, you've done something wrong. You've done many things wrong. You didn't have the right backups. You didn't have enough redundancy. And now you're trying to get this disk that's falling apart to give you your data. But sometimes it's what you got to do, I guess.
Sometimes you inherit a client, and that client didn't always make their decisions with you at their shoulder to guide them.
Yeah. And, laptops don't fit that many disks to let you mirror stuff or whatever. Although I actually managed to find a 256 gigabyte NVMe that fits in the 4G modem slot in my laptop so that I could mirror my disk.
Nice. So using DD Rescue, you can have it kind of read the disk multiple times, and it can kind of get up to the part where the bad sector is and then skip ahead and then go back afterwards and kind of just inch its way back until it finds the bad sector, and it will give you an image with just that dead sector in it.
Yeah, it's the storage version of having a really intense, unpleasant argument with your spouse where you can only get so far before everything just breaks down and you got to stop for a while and everybody cool off. And then you can go back and you can, maybe work around what you start off with. So in DD Rescue, that basically means that you're going to make one pass over the drive and get all the data you can as quick as you can. And there's going to be areas that, you can't read. You may even just come to a point where the disk overheats or whatever, and it stops responding entirely. But it might respond again if you give it some time to cool off.
Yes. Or put it in the freezer.
Yeah. Or you can try putting it in the freezer if you've got a stiction problem, or, smack it gently with a mallet. There's all this crazy stuff going on. But the important part from DD Rescue's point of view is it's taking a pass and it's saving a state. It knows what sectors it's gotten and what sectors it hasn't gotten. So when you run it the second time, it's not going to try to read the ones that it already got an answer for. Now it's going to start trying to fill in those holes. And as it goes, it will try smaller and smaller operations on the drive, because sometimes you may not be able to successfully get a 1 meg operation to complete, but you can get a single 4K sector out. So DD Rescue will, nibble around the edge of the holes and get as much of your data as it possibly can. But it's going to take a very, very long time and be very, very fiddly. And if you're down to the point of having to use DD Rescue on a drive, you're probably not getting most of that data.
Yeah, because you can also run into problems where trying to read a certain part of the drive makes the drive basically spend many minutes retrying before it even returns a failure. And you can get, basically make the drive go catatonic where you're going to have to start over and hopefully, skip that part and go to the next one. But yeah, if you're having to do this, you've already, failed to have backups and failed to have redundancy and failed to not use a disk that was starting to go bad. We get questions all the time about people who are just like, well, I have these old disks and they're not great, but I can kind of use them. And it's like,
no,
you could, but it's like Jim was saying earlier, when there's mold on your food, don't try to eat around it.
All right. So another story that you wrote this week was about the AMD Ryzen 4000 desktop APUs, which no one's going to be able to get their hands on unless they buy a pre-built machine, it looks like. Eventually,
in theory, they'll be open to the enthusiast market, but for the foreseeable future, only OEMs and system integrators are going to get them. And system integrators, from AMD's perspective, doesn't mean the same thing as it does from mine. I asked AMD what that meant, system integrator, because they never define the term. They just say it's only going to be available to OEMs and system integrators. They took a couple of days to finally get back to me, and when they did, their answer was basically an OEM is multinational and a system integrator is an OEM, but pretty much only in one country. So, you're not talking about your local PC store. You're basically talking about, it's going to be a real OEM, somebody who's buying, chips in the thousands or the tens of thousands.
And so these are AMD desktop CPUs with onboard graphics.
Yeah, they are. When AMD says APU, that's what they mean by a CPU with integrated graphics. The interesting thing is they are and they aren't desktop processors. I mean, they completely are, but their actual genesis is this is basically the Ryzen 4000 mobile CPUs, which are frankly fantastic, just scaled up into desktop size frequency, thermal, and power budgets. And these are not going to be amazing to anybody who's, already working with like a Ryzen 3000 desktop CPU. They perform very, very similarly. But it's pretty cool that for, roughly the same price as you might spend on a Ryzen 7 3700X, you can get a Ryzen 7, I think it's 4700G, that is about the same, TDP. And, it's got 8 Radeon cores as well as the CPU. I would actually totally be in the target market for these things if they would sell them to me, but they're not going to sell them to me. So,
They sure made you do some maths, when it came to the benchmarks of these, or what the expected benchmarks will be.
Yeah, they did. I was very disappointed with them about that because, for the last several product cycles that I've been doing CPU reviews for Ars Technica, Intel's press decks have been weaselly, to put it mildly, but AMD's press decks have been very open and straightforward, and like, here's the numbers, and they give you these fantastic looking benchmarks, and you have to tell your readers, of course, we won't really know until people get their hands on them. But then you get your hands on them and you run the benchmarks, and hey, you get these same numbers they did. This is good, and it's good in all the ways they said it was. You don't have to do any guesswork. Whereas with Intel, I've frequently had to do things like, they say, oh, well, this is X% better than Y. And, now you got to go try to find like that benchmark for something that they said it was, whatever percent better than that, and compare it to it. It sucks. And that's exactly what AMD did this time with the APUs. They did generation on generation comparisons, but the generation on generation was versus the last generation of APUs. And the last generation of APUs, it wasn't the full product line. It didn't go any higher than Ryzen 5. So when they say something like, oh, hey, we've got 205%, gen on gen, for our new Ryzen 7 4700G, well, that's really misleading because you're comparing it to a freaking Ryzen 5.
With what, a quarter of the power budget or something?
Yeah, I think so. The new ones, they have 18 models now with the new APU launch, but it's actually a lot simpler than it sounds. It's 5 base models. All models have both a Pro and a non-Pro variant, and Pro for the most part means full memory encryption and the little corporate management features. And all but the bottom end of them also have high TDP and low DP versions. And all the high TDP is 65 watt. All the low TDP is 35 watt. So it's a Ryzen 7, a Ryzen 5, a Ryzen 3, an Athlon Gold, and an Athlon Silver is really what it boils down to.
I was speaking to a friend today about the 4000 series, the laptop ones, and he said to me that they're all fine and dandy if you just turn them on, use them for a few hours, turn them off. But if you are in an enterprise situation where they're left on for days and days and days, you end up getting weird crashes and something about the drivers not being good. Is that something you've ever experienced?
It's not. I haven't had my hands on tons of Ryzen 4000 laptops. I've only had two. I've got an Acer Swift 3 that's still on my bench that has it's got a Ryzen 7 4000 something or another, and the U series. And I also had an Asus Zephyrus G14 that had, the big boy, the 4900 HS, gaming CPU. But I mean, I've had both of them on and running benchmarks and doing stuff for, days and days on end. And I have not had any reliability problems out of either.
Yeah, like that type of, the problems you're describing sound a lot more like software drivers and less hardware.
Yeah, but if the drivers aren't available for Linux, then it's not, even with the latest drivers, if you're still having these issues, then what can you do apart from just use something else?
Usually it's more with the ancillary hardware in the laptop than, the APU itself, honestly. Like, for example, the Zephyrus G14 was a nightmare to try to work with under Linux but it's not because of the 4900 HS. It's because that it also had an NVIDIA RTX 2060, mobile in it, or GT. I forget who's the G or the R or whatever. But anyway, a 2060 mobile NVIDIA discrete GPU in it, as well as the onboard Radeon GPU. And Linux and hybrid GPUs and laptops don't really get along very well. So that was really the only thing I had problems with.
Your solution is run Windows, Alan?
Not necessarily, but...
well, it's certainly not run FreeBSD.
FreeBSD's got the same graphics drivers as Linux now. So, if it'll work on Linux, it'll work on BSD. And if it won't...
We already established it didn't work on Linux, so...
Yeah.
So good luck.
Yeah.
All right, well, let's move on to a bit of free consulting. If you want to get in touch with us, the best way is show@2.5admins.com. Send us an email with your questions for Jim and Alan. And if you want to support this show, you can do so on Patreon. The details for that are at 2.5admins.com. And thank you, everyone who is supporting us. It is really appreciated. So, Michael wrote in, if I find some useful utility online and it's not in a main repo, it's not in a PPA, it doesn't have an RPM, it's not in AUR, and I need to do the holy trinity of configure, make, install, what's the best way to manage updates and or remove it without resorting to the type of manual seek and destroying that Jim had to do recently? Should I just package it myself? And he's referring to a post you put up on your personal site when nothing else will remove a half-installed.deb package, where you had to go to quite some lengths. That was, I was quite wincing reading that.
Yeah, that's unpleasant. I mean, to be fair, that's not a situation that you're going to have if you're working with unpackaged software, because you just RM it and you're done. The issue is that if you end up with a broken .deb package, getting rid of it and getting your package manager back into a usable state can be kind of a nightmare. It's not as simple as just delete something and go.
Right. Well, I think the question is probably a bit more that, your typical make install is going to scattergun stuff all over the file system. And how do you actually clean it all up?
Yeah.
And I think the right answer to that is likely to do something with the package, because most package managers keep track of all the installs, all the files that a package installs, so that you can uninstall them. But really, there's a question of whether you should be using software that is not available in the repo, because how do you get it updated and how do you keep track of it? Every Linux distro is a bit different as far as the breadth of what's included in the packages. I'm not that used to the Linux model of having a bunch of different repos and a bunch of different package managers like APM or RPM and AUR and so on. The FreeBSD package repo has 30,000 something apps in it, but when something's not in there, it's either add it or find something else, usually, because just scattergunning stuff all over your file system is weird. And more importantly, it's not reproducible, right? The thing we try to tell people about being able to manage your server is you have to be able to redo anything you did.
There's a couple of different answers here, honestly. It depends on what kind of software we're talking about. If you're talking about a simple and fairly self-contained piece of software that basically just, runs directly out of one executable, that's a whole different story from something that, wants to spew libraries over, 5 different directories on your system. And you have, if you're doing that, from Cowboy compile, /configure, make install, You actually have more problems than just how do I update it. You also have to ask yourself the question, is this going to overwrite a system library that my actual package manager has been managing? Which means at this point, you've committed yourself either to one, actually reading through the make file and figuring out all the things that, this build process does, or, just YOLO swag, jump off the cliff and see what happens, which obviously I don't recommend the latter. I don't recommend the former either, because the odds are real good you don't need that thing that bad. There's so much well-packaged open source software out there in proper repositories that there's just honestly not that much need to go that far off the reservation. If you really need it that badly, then yeah, if it's not already packaged, then you should probably take on that job and package it, which again means you need to understand all the things that it's doing as you build that package. And now, you've taken that thing on. It's your baby. Are you ready for another baby? If you're not ready for another baby, don't do that.
What if you package it as a snap?
Well, if you package it as a snap, then, now you're saying, well, okay, I know I can take away all the things that it dropped, and I know that all the things that it dropped won't interfere with the rest of my system. But as far as the rest of the quality of it, who knows? And, in theory, who cares? Because it's, all in this little container. And that's sort of fine as long as you're not worried about security problems caused by the fact that now you have 20 different versions of libfoo in 20 different containers on your system. And when one exploit in libfoo comes out, now you have to worry about patching it in 20 different places, which may or may not happen.
Yeah, and on FreeBSD, the package manager has an audit tool that will actually compare the installed packages you have against the list of known vulnerabilities and be like, hey, these 3 things you really need to update because there are known vulnerabilities. If you have software you install that's not through the package manager, it doesn't know it's there and doesn't tell you, hey, you really need to update that. And you think you're installing your updates because you ran your package manager update and you updated everything except for that one runt piece of software that's not in the package manager.
Alan, I don't know the answer to this one, but in a FreeBSD system, if you cowboy compile something, and let's say that you've got libfoo that's been installed from packages as a dependency of something you've installed the proper way, but maybe that's in user local bin, and now you run this cowboy compiled thing and it drops libfoo in user bin. Will the audit even figure that out? And the fact that it's higher up in the path and it's going to end up getting used by things that maybe it shouldn't?
Probably not, actually. That's a good point. Because the other thing I was going to mention is if you do need to do something like this, almost every configure script, all the automake ones and so on, support -- prefix equals, so that all the paths it installs to get a prefix. And so FreeBSD uses that so that every package you install that isn't part of FreeBSD itself is under user local something, so that your operating system and your packages are separate. You could do the same thing and with your custom compiled software and put it under user custom or something, and then add it to your path. And that way all the custom stuff is definitely off in this side directory, and I can always clean it up nicely or whatever. But yeah, if something just randomly sticks a library somewhere where it's not expected to be, that can be a problem. If it overwrote the correct library, then there's a package manager command, package check, that will be like, hey, the checksum of that file is wrong. Would you like me to reinstall the package for you? But yeah, if it just stuck an old version of OpenSSL in the wrong place, so that everything started using that instead, that could cause all kinds of havoc.
So in conclusion, don't use something else that's in a repo.
Yeah, or make a package. Oftentimes making a package is pretty simple. I don't know the details on most Linuxes, but on BSD, it's like, here's the GitHub repo, here's the hash, it uses automake, and put the files over here. You write a short text file that describes it, and then now you can have packages.
I'm not gonna lie, making a deb is way more complex than it ought to be. I've done it, but it's one of those things, it's complicated enough that if you're not doing it like once a week, you're going to forget, and it's not intuitive, and you're not going to remember when you go try to do it again.
You're telling me you haven't got documentation for it? That's
the problem. There's 500 different, sets of documentation telling you how to make a deb. And some of them assume that you're working with, Launchpad on Ubuntu, and some of them assume that you're working in plain Debian, and some assume this, and some assume the other, and they all conflict and, tell you different things. And even more frustrating, if you're somebody like me and, you're building software in a relatively high level language that doesn't even need compilation, like here is a script it needs to execute. Here is a config file. It should go in a directory and etc. That should be really, really easy to package. It isn't, because these package systems assume that they're going to be compiling, C software. And everything about that system is set up around that incorrect assumption. It's a giant pain in the butt.
Yeah, the BSD one's a bit easier, but you're literally using make files to do everything. Like make files that download things for you and make files that run the configure script and manage all the patches. And yeah, if you're not that familiar with make files, it gets the water gets deep real quick.
Well, I'm going to channel Popey, who calls the show 2.05 admins. He would say it's much easier to make a snap, and you should look into that.
I have looked into it, and no, it's really not much easier.
All right, fair enough.
The nice thing about the way FreeBSD packages are built is you make the manifest for it and so on, but the building happens centrally, and each package is built in a clean environment with no other files around. And so it's, each package works as if it was something like a snap, but you can just install a bunch of them on your system. But you make sure that you don't get any weird contamination from other things that might have been installed in the system where you were trying to package it.
Fair enough. All right, well, we'd better get out of here then. Remember, show@2.5admins.com if you want to get in touch. We'll be back in a couple of weeks then. Until then, you can find me on Twitter @Joe Ressington.
I'm @JRSSNet.
And I'm @Alan Jude.
See you in 2 weeks.